Hi. So today we're going to be talking about the periodic table of elements. What you will need for this lesson is a periodic table. Today we're going to talk about the organization, the beginning of the periodic table, and trends you can find on the periodic table to help you identify elements and their chemical properties. To get started, we first need to know, where did the periodic table start? The periodic table started with Dmitry Mendeleev. He was a Russian chemist back in 1834. He organized and developed the periodic table of elements. He arranged the elements in a way that was unique at the time. It allowed him to predict what elements were before they were even discovered. Element number 101, mendelevium, is actually named after him because of his achievements in the organization of the periodic table. The periodic table itself contains all the chemical elements. It is arranged in order of increasing atomic number or increasing number of protons in each element. It contains over 100 elements, whereas the first periodic table only contained 63. So the periodic table is arranged in multiple ways. The first way we're going to talk about is groups or families. These are going to be your vertical columns on the periodic table, as you will see here. There are 18 total. The elements in each group or family have similar chemical properties. Valence electrons can also be determined for group 1 and 2. Also, groups 13 through 18. Groups 3 through 12 work a little bit differently. So to determine the number of valence electrons, if the group number is a single digit, the group number or the number of valence electrons would be that number. For example, group 1 has 1 valence electron. Group 2 would have 2 valence electrons. But if the group number is a double digit, it would take the number of valence electrons would be the second digit, the digit in the ones place. So, for example, group 15 would have 5 valence electrons. Here you'll see that we have groups 1 through 18. Group 18 and group 1 are special. Group 1 are going to be alkali metals. Those are going to be extremely reactive with water, and they have a 1 electron on the outer shell, which makes them very unstable. Group 2, alkaline earth metals. Those are still fairly reactive and have 2 electrons on the outer shell. Groups 3 through 12 are transitional metals. These are metals that can conduct electricity very well. Group 17 are halogens. They're highly reactive. And when you combine them with metals, they form a salt. An example of that would be sodium and chlorine. You get salt. And group 18 are noble gases. These are very stable. They do not react. They're inert. They have a full outer shell, which causes them to not bond with other elements. The second way that we organize the periodic table is in periods or rows. These are going to be horizontal rows on the periodic table, like here. There are 7 total rows or periods on the periodic table. The number of energy levels or outer electron shells can be determined by the period that the element is in. For example, calcium belongs in period 4, so it has 4 energy shells. Oxygen is in period 2, so it has 2 energy shells. The way that I like to remember periods is you think of it like a sentence. It goes from one side to the other and ends. Just like a sentence goes one side to the other and ends with a period. Here you see an example of period 1 highlighted in green and period 7 highlighted in blue. Some trends that are on the periodic table are going to be the number of protons. The number of protons are going to increase as you move right and down the periodic table. Metals, there's a trend with those. They're going to become more reactive as you move to the left side of the periodic table. And the atomic radius, or the number of shells, increases as you move down in your group or family, as you go down in the rows or periods. All right, so let's do our 5 checkpoint questions to make sure we understand what we talked about today with the periodic table. Identify 3 elements on the periodic table that are considered to be noble gases. What you are going to do is you're going to take your periodic table. You're going to find group 18 over here. And all of these are going to be your noble gases. We start here with helium, then we have neon, argon, xenon, radon. All of those are going to be noble gases. Question number 2, identify 3 elements that have a similar chemical property to magnesium. So when we talked about finding similar chemical properties, a element in the same group or family is going to have similar chemical properties. So first thing you have to do is identify and locate magnesium on your periodic table. Magnesium is going to be in group 2. So it's going to have similar chemical properties to calcium, beryllium, barium, radium, any of those elements located in group 2. What element is located in group 13, period 3? So this is kind of like a search and find. You're going to go across 13 and down 3. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and down 3, 1, 2, 3. Located in that spot on the periodic table, you would find gallium. Let's try another one. What element is located in group 17, period 5? Group 17, period 5. Don't forget, even though there is not an element here, that is still period 1. So you have 1, 2, 3, 4, 5. So located in group 17, period 5, you will find iodine. And our last question is, list the following elements in order from least reactive to most reactive. So remember, all of our metals get more reactive as you move to the left, as you go to group 1. So we have gold. Then the next one you would find as you're traveling to the left would be iron. So the most reactive is going to be sodium because it's in group 1. Today we talked about the periodic table and trends with the periodic table.